In last class, we saw about EBGP and IBGP, as well as we saw the difference between them. Not only just internal and external, there is also difference in forming adjacency, forming neighbor. EBGP by default will form neighbor if neighbor is directly connected. Next thing is, inside IBGP, we need to have a full mesh. The reason is route learned from one IBGP will not be given to another IBGP. This point. The route learned via IBGP or never propagated to other IBGP peer. So they need full mesh. Now, before we move on to next chapter, I think I should do a lab for you. Before we move, let me use Notepad to finish the basic IP address and OSPF configuration. Why do I need OSPF? In order to reach between R1 and R3, I need OSPF. So not only to provide reachability, also for R1 to form neighbor with R3, BGP neighbor, R1 should have reachability to R3. Only then it can do three-way handshake. Only then it can form IBGP neighbor. Very important. When you tell a neighbor address in BGP, that neighbor address should be a pingable address. So let's bring the IGP using Notepad. I don't think any of you will have any difficulty in understanding what I have written. Now, R1 configuration is khatam. Let's go to router 2. On router 2, loopback will have 2.2.2.2. And F00 will have 10.12.02. F01 is going to have 23.2. There's nothing more I'm going to do here. I hope you all follow this. And one more router inside this autonomous system. F00 is 23.3. But F01 is facing outside, so there is no need to run OSPF there. And the network is 11.34.34. 1. The mask I have given is 30. That's it. See? No OSPF on the outside interface. Once I paste this, I expect a reachability from R3 to R1's loopback. All right. Now, let me try pinging Yeah, which means OSPF is good. Let us go to the last router, which is in the autonomous system 200. No OSPF needed here. I remove this. No OSPF needed. So I remove this. This is also not needed. This is going to be 2. No OSPF. Nowhere on this route. Okay. Now, router 3 and router 4 should ping each other. Only then we can configure router 3 address as a neighbor. First, the address should be pingable. You need to verify always. 11, 34, 34, 1. It is pinging. It will. It is. And also you need to make sure this particular address is directly connected endpoint. Yeah, it's connected on the other end of this wire, F00. We have 11, 34, 34, 1 on F01 of router 3. So now it is ready for us to start BGP. I'm on router 4. I say router BGP 200. And I can say straight away neighbor 11, 34, 34, 1. Remote AS is not 100. Sorry, it's not 200. It's 100. Listen carefully here. When we say our address, our autonomous system 200 and our neighbor autonomous system is 100. When we say this, when we say different number, 200 and 100, router 4 understands that this is an EBGP neighbor. EBGP is identified not based on this command. Because it says remote, it doesn't mean that it is EBGP. No, no, no. That is not the one which makes router 4 to understand router 3 as an EBGP. It is this autonomous system number. My number is 200. R4 says, என் நம்பர் 200. இந்த பைய நம்பர் 100. அது எப்படி நம்ம ரெண்டு பேரும் ஒரே நாட்டில் இருக்கிறதா அர்த்தமாகும்? அப்போ அவன் வேற வெளிநாடு, அவன் வெளிநாட்டுக்காரன். This is how it understands whether it is உள்நாடு or வெளிநாடு, whether it is IBGP or EBGP. It is not because of this command. மறுபடியும் சொல்றேன். Remote AS is a common command for both IBGP and EBGP. It is this number. All right. Now let us verify this by typing the command show IP BGP summary. Show IP BGP summary. You can see that this router 1's at router 3's address configured. The OSPF that we are running is version 4, and the autonomous system to which the neighbor belong to is 100, whereas the local autonomous system is 200. Now R4 understands that this neighbor is an EBGP neighbor. To this neighbor, Neighborship should form only if it is directly connected. That's the policy, right? We saw that in the presentation. EBGP should be directly connected. IBGP does not need to be connected directly. So how it knows that it is EBGP? Because of the different autonomous system it knows. Because it knows that it is of different autonomous system, it expects the neighbor to be directly connected. Now, more about this will come later. What else we learn here? We see here there is no neighbor come up. So far neighbor is just configured. So far no neighbor is learned. No neighbor has come up. That neighbor has never come up. The neighbor has never come up. If it is up, it will show you some timer, how long, how many seconds or how many minutes the neighbor is up. Now, what is the state here? Idle. Idle, active, these are all not good. Idle means what? I cannot find neighbor. The other side is not supportive, that's the meaning. Active means what? Sometimes you will see active here. Active means what? I'm trying to find route reachability to the neighbor. But here the reachability is already there. In the routing table, you have a route. Even pinged and we saw. It is pinging. So it is pinging. It even sent the TCP handshake. But the problem is router 3 is resetting. The configuration on R3 is still not configured. That's why. Okay. Now let us go to router 3. On router 3, we say router BGP 100. Router 3 belong to 100. Neighbor is 11, 34, 34, 2. Remote AS is 200. You see, it's EBGP neighbor. And you already see that BGP adjacency neighbor change state up. The neighbor has come up. It's because we already finished on R4. Now, if you go back to R4, you can see even here. In this command, if I type again, you will see the current status. Currently, for last 30 seconds, the neighbor is up. So far, 4 packets have been sent and received. Earlier it was 0, 0. 4 packet has been sent and received. Prefix received is nothing. What does that mean? R3 has not advertised anything. You need to understand. BGP is not going to advertise until you say network advertise this. So far, we have never used a network command. We simply say neighbor. This neighbor command will not advertise this network. This is only to form neighbor. Neighbor command will not advertise network. This is just only to form neighbor. Okay. Now, if you want to learn a network from R3, R3 should advertise. Now, I'll go to R3 and say, hello, R3, can you please advertise this network 3.3.3.3 and mask is 255. We did this in the previous class. I am repeating again. Now if you go to router 4, you will see here, instead of 0, you will see 1. Let me put the command back. Look at this. And if you see the output, it is not the same. Earlier, when nothing was received, this command was giving me only 2 lines of info. But now it gives like many lines of information. Yeah, many lines of information. What does it say? It says that the local router ID is 4.4.4.4. Autonomous system is this. BGP table version is 2, meaning changes happen to this table. This was 1. Now this new network got added, no? Got learned, no? So it is. See, even the routing table will also get impacted. So it's 2 now. 1 network entry using 144 byte of memory. 1 path entered, 80 byte of memory. 1 by 1 path, best path attributes. This shows that how much of memory this one particular prefix that cost. Now, what is that prefix I want to see? Use the same command without summary. This is that one network. This is the network that we advertised on R3. And you see, next stop is router 3's address. Router 3's address. And router 3 is giving this from the autonomous system 100. Correct, no? Router 4 is in autonomous system 200, but this is learned from autonomous system 100. Who gave you? Who gave this? It is this router given this. Who is this? It's R3's F01. Now, this is router 4 learning from router 3. Now let's go and check the same command show IP BGP on R3. When you check on R3, it will show you what it is advertising. R3 says, I am advertising. Where it is saying I am. This is what meaning of I am. Next stop is none. I myself. No one is next stop, man. It's me. I'm advertising. Okay, so that's why it is not showing any path. It's not saying I'm learning from that autonomous system. But here you can see the path is 100. It learns from 100. Okay, now I want to learn some network from R4 on R3. So what I'll do, I'll go to R4 and advertise the new bank. Router BGP 200, network 4.4.4.4, mask, done. We have advertised this network. Now locally, let us check first. Show IP BGP. It says that 4444, I'm advertising, locally advertising. Now let's go to router 3. Earlier you were only seeing what you were advertising, but now you can even see what you learn. You are learning about 4444 from R4's F00 interface address and from the autonomous system 200. Okay. Now, if you check the routing table, show IP route BGP, you can see 4444 learned via BGP and the administrative distance is 20. 20. Yeah, eBGP administrative distance is 20. Do anyone remember what administrative distance for IBGP? 200. Correct. Now, my question is, will I be able to ping this 4444 from this router 3333? Yes, why not? Let's try pinging. Ping using source 3333 also it will ping. Without source also it will ping. Okay, so using BGP we have learned a network and we are able to ping. Now let's form IBGP with R1. As I said earlier in the previous chapter, IBGP neighbors do not need to be directly connected. They don't need to be directly connected. Yeah, there's no need for direct connectivity. So if R3 can ping R1, ping 10.12.0.1, you can do the neighborship also. If this ping is successful, you have reachability. If you have reachability, three-way handshake is possible. If three-way handshake is possible, BGP peering is possible. Yeah, let's now do that. Between R3 and R1, I'm going to form a neighbor. Config T. Router BGP 100. Neighbor is 10.12.0.1. Remote ASS. Listen. Even for IBGP, the command is remote AS. It's not a local AS or it's not something else. So this 100 that I put, and the local is also 100. This makes this router to realize that this 10.12.0.1 is a local neighbor, is an IBGP neighbor. He need not to be directly connected. Understood? There is no command to specify that this neighbor is an IBGP. If you see, for eBGP also we gave the same command remote AS. For IBGP, remote AS. Any change in the syntax? No. Then how it knows? By comparing the neighbor's autonomous system with its own. If it differs, then it is eBGP, then it has to be connected directly. If it is not differing, if it is same, then that neighbor can be remote. Okay, I have finished configuring one side of IBGP. Let's go verify before we go further. Show IPBGP summary should show you that this IBGP neighbor is already configured, but it has never come up so far. Let's try to bring it up by going to R1, configuring BGP. Router BGP 100, neighbor 10.23.0.3, remote AS 100. The moment I hit enter, it will start doing three-way handshake and the neighbor will come up. Now it will come. Once the three-way handshake is done, it will come. See, I can see the neighbor has come up. Now let us go back to R3 and check this. You see, IBGP is there up for last 10 seconds. From router 1, nothing has been learned so far. The reason is on R1, nothing is advertised. That's why. It is okay. Our aim is not to ping now. Our aim is to see how a neighbor can be formed when they are not directly connected. All the protocols that you learned so far, all the routing protocols that you have learned so far, you saw they all need to be directly connected. But these two are not. Okay, next thing is R4 was advertising something to R1. And will this R1 reflect in, sorry, to R3? R4 was advertising 4444 to R3. We saw that even in the routing table. Now, will this route be advertised to router 1? Let's go see it. The command to see that is show IP BGP. Yes, we do see that. This is learned from router 3, and this is learned from whose address is this? Router 4's address. From where router 4 learned this network? It learned from autonomous system 200. Sorry, from where this network is learned 4.4.4.4, it's learned from autonomous system 200. Now we see something here. What is R? R means rib failure. Rib is a soft bone in our chest. It's not that rib. This is routing information base. Routing information base failure. Meaning what? Meaning is unable to use this route. That's the meaning. Routing information base says, I cannot use this. Why? Because OSPF has already given this to me. That's true. We are already running OSPF on R3's loopback. So using R3's loopback OSPF, this 3333 has already learnt in R1's routing table. Let me show you that. It is already learned through administrative distance 110, which is OSPF. The IBGP's administrative distance is 200. That's why it is not using it. IBGP's administrative distance is 200. OSPF is 110. So it says I will use OSPF. I cannot use yours currently. Yeah, it says I cannot use yours currently. Okay, what is next? What about this one? The star here means valid. This greater than symbol is best. See, I couldn't see the best here. For 4444, I couldn't see the best. Because of that reason, in the routing table, you will not see route. Three you don't see because of OSPF. OSPF AD is better than IBGP. But 4444 is also not shown here. The reason is this. The reason is this next hop is router 4's address. Can router 1 ping this router 4? No. Router 1 cannot ping this router 4. When the next hop is unreachable, it cannot use it. When the next hop is unreachable, it cannot use it. That's why it says not. It is only valid, not best. It's not having that best symbol. It is valid because BGP gave. It is valid, but can't use it because the next hop is unreachable. Don't worry about this next hop story. I'll be teaching you in another chapter. Now, before that, I'm going to solve this problem like this. Router BGP 100, and I put this neighbor 1 next hop self. I'm telling router 1, I'm your next hop because R1 don't know R4. So I'm saying I will be your next hop. R1 knows R3, no? R1 knows R3. So after doing this, whenever you do some changes like this, it is good to refresh BGP. How? Clear IP BGP star soft you give. If you don't give soft, if you don't give soft, it will be a disruptive one. It will discard and then re-establish. Better give soft. So clear IP BGP star soft. After we do that, go to router 1 and check. You see the next hop is changed. And this is now valid and best. Besto, best. Valido, valid. Okay, now let us see the routing table. Definitely you will see a route in the routing table. And you see administrative distance 200. As I told earlier, eBGP is always preferred over iBGP because eBGP's AD is 220. iBGP's AD is 200. We have learned the route of R4 on R1. But if we expect ping and all will not happen. Why ping won't happen? Because R2 don't know anything about 4444. Go check on R2. Show IP route 4444. Because this don't have a route, packet cannot pass through R2. It will drop. That's what we learned in the previous class. To solve this problem, you need to form full mesh. Okay. Yeah. Let's form full mesh now. Go to router 2 also. Say router BGP 100. You got a neighbor 10.12.0.1. Remote AS is 100. And you got another neighbor on the right, which is 10.23.0.1. And then what? If you say here it's not enough, you also need to go to router 3 and say that. And also on router 1. Router BGP 100. Neighbor is 10.23.0.2. Remote AS is 100. Also to this you should say next up self. Don't worry about the next up stuff. I know we will be learning that more clearly in coming chapters. Now on R1 also I have to say you got another neighbor. The neighbor address is 10. 10 10.23, sorry, 10.12.0.2, remote access 100. That's all. I'm expecting two neighbor on R2. It should say neighbor up. Show IP BGP summary. I can see one neighbor is already up. Oh, okay. This I made mistake. It's 23.3. IP address mistake. Okay. Now the other neighbor will also come. Show IP BGP summary. Now we have full mesh, meaning I have three routers. So each router should have two IBGP neighbor. R1, if you check, show IP BGP summary, you have two neighbors. This is what full mesh. And you have done two network from router 3. Now let's check the routing table. And I try to ping 4444, which is of router 4. Even now I will not be able to ping. The reason is this. The packet will go, but router 4 do not know about this 10.12 network. So better you advertise the network from R1. Router BGP 100, advertise that loopback. You see, because you are advertising this network, you should source it from this network. When you advertise this network, only this R4 will know. R4 will not know about 10.12. You're not advertising 10.12. As I told earlier, the neighbor statement will not advertise. It will only form neighbor. Whatever you put under network is only advertised. So go to R4 and check whether you are learning 111. Yeah, you are learning 111 from Autonomous System 100. Show IP route, BGP, you are learning 111. So R4 knows only 111. Now, if you are pinging from R1, you should not ping like this. You should source it with 11111. Because 11111 is what R4 knows. So you are able to ping. You can also trace route. You are able to reach. So we have seen a very good example of eBGP, IBGP full mesh, whatever we have learned in the previous class. Also, we have learned something called next stop self. More details of this is coming in the next chapter, so no need to worry now. All right? Any question?